All right, so this is going to be the network security domain that we're going to talk about. And specifically, it gets into some pretty cool stuff. We'll just go through and talk a little bit about infrastructure, devices, and a whole bunch of things that I think you need to be cognizant of. It's a good idea for you to have an understanding of the processes that TCP/IP uses to know how specific attacks happen. And in order for you to be awesome and the next generation of cyber ninjas, that's what I would recommend for you is to go through, look at connections, look at services, play with some of those games that I showed you online. And if you're weak in any of these areas, it would do you well to make sure that you have a fundamental understanding of how things work. And you can either watch this video again or any video that's out there online because you definitely need to know this in order to talk intelligently in this field. So we'll get into the OSI model, talk a little bit about ports and protocols, some of the network typologies, cable types, and then get into some devices. So many of you have seen this before, and specifically, this is on the left-hand side, the OSI model, and on the right-hand side is how the OSI model maps to what is called the TCP/IP architecture and the TCP/IP model. So working with the TCP/IP suite on the right-hand side, it has a lot of relevance when we get into talking about the OSI model. So TCP/IP precedes the creation of the OSI model. And so a lot of times, if you know the fundamentals here of how these work, it's easy for you to understand what layer typically a device will talk in or an application will send something to another thing. And this is how they map to each other. So over on the right-hand side, we see the application layer of the TCP/IP model, and that maps to the OSI model in the application, presentation, and session. The host-to-host maps with the transport. The internet maps with the network. And the network maps with the data link and the physical. So check it out here whenever we get into talking specifically about the OSI model. One of the mnemonic ways to remember this is all people seem to need data processing. If you say it to your muted microphone here, you can say all people seem to need data processing. And I've heard it a number of different ways. Some people use this one. This is the one that I usually will teach. It goes from layer 7 down to layer 1. So all people seem to need data processing, application, presentation, session, transport, network, data link, and physical. Some people teach the other way. And the other way is, please do not throw sausage pizza away. I know, both of them are kind of silly, but it doesn't matter to me which one you remember. There will be probably 4 or 5 questions um, that are not going to be asking you specific about layer 5 is the session layer. It'll say something about layer 5 in the question, and then from that you can probably deduce that, hey, I can eliminate 2 of these answers because I know layer 5 is the session layer. And if you do that, then you give yourself a 50-50 chance on any question just by eliminating 2 answers, which is the technique that I usually will teach. So this is it. This is where I typically will start with anything and everything in the training, and it's super important for you to know that the OSI means open systems interconnectivity, and all people seem to need data processing. So how does it work? Well, if you have a client and it needs to talk to the server. Let's talk about this for a second. If I have a web browser, and the web browser needs to go out and talk to my banking server, or maybe you want to send an email to me that, hey, you know what, I want to take this course online, the price is right, I want to take this course. Well, at layer 7 in your email client, you go, maybe an Outlook or whatever email client you're using, the application layer, that's an app. So you launch Outlook, you go into Outlook, you type in the message. The message typically will get saved into an HTML format, which is the presentation layer. And then what it does is it goes through and does this thing called encapsulation. And the encapsulation is super important because it traverses the stack. So it goes down the stack here, goes across the medium, whether that's wired or wireless, and then goes up the stack to the other person's Outlook on the other side of the world, or wherever you're sending it to. And so at each layer of the OSI model here, remember, all people seem to need data processing. Each layer of the OSI model gets appended to or added to specific information that's pertinent to that particular layer. And then it does the reverse on the other side of the wall when it's at the receiver. How does it, an easy way to look at it here is the top of this encapsulation, the data, goes down and is added specific, and you see it here, it gets added as it goes down the stack. Kind of looks like something out of the Aztecs or the Incas or something here with this little pyramid. But essentially, this is usually the diagram that you will see people draw whenever they will try to explain how encapsulation works. But it allows a transport protocol to be sent across the network and then utilized by any equivalent service or protocol on the receiving end of the house. And it's kind of neat how specifically it works. So the application layer, a lot of times this is what we're most familiar with. This particularly has the HTTP or HTTPS. Anything that we're more familiar with is probably up here at the application layer, and that's super important to know. Any of the formatting, like how is the document going to be saved? Is it a ASCII file? Is it a JPEG? Is it a video? Is it an HTML? What's going to be the format? How is the extension of that document going to be saved? That's typically what we see for the presentation layer. The session layer will be anything dealing with connections over a network. How can I sniff out the network, and what do I know specifically if I'm going through and doing any communications on the network? And that would be things like NFS or NetBIOS, structured query language or SQL. Anybody that's using remote procedure calls, whether it's like an MS SQL, MySQL, or big time applications like enterprise level applications like SharePoint or anything like that, would use some of these calls behind the scenes that are happening on the back end. At the transport layer, this is where basically we see the delivery being made to the control of a specific packet to an address, which is the IP layer on the network. So the transport would actually be how's it going to get there, and then the network would be where's it going on the network. And some of these routing protocols, a lot of my Cisco friends are deep in the bowels of these routing protocols. Typically, you'll see things like OSPF talked about a lot, maybe Internet Group Management Protocol. So a lot of these are out there, but probably the most two well-known that we see are the IP and then the ICMP, which is commonly known as the ping command. So talk a little bit about these top two. because you will absolutely see these on the exam, ARP and RARP. So ARP is responsible for resolving IP addresses to NIC or MAC addresses. So ARP resolves an IP address to a MAC address. RARP, or reverse ARP, takes the MAC address and resolves it to an IP address. So if that's confusing, rewind it, listen to it again. So ARP resolves the IP address to a MAC address. And RARP takes the MAC address and it will resolve it to an IP address. So that's the difference between the two, and you need to know that because you'll see that on the exam. The physical really are the easiest part because that's really the wires or the waves over the internet or the wireless access points. So when you see any of these right here, we don't see a lot of the speeds of particular types of cables on the exam, but usually on the physical layer, we've seen a lot of wireless questions starting to come to life lately. Just another example of how each device works here at a particular layer within the OSI. Again, talking about how the encapsulation works as it goes down the OSI layer. Remember, all people seem to need data processing. The message can be compressed into a standard format or maybe encrypted. You negotiate any session that needs to happen for transmission. For an end-to-end connection over the transport layer, you send out specifics on where it's going on a network via datagram. You can send it in chunks through that data link over a frame. So basically, it's like you send, instead of a huge mass, you break it up so then you can just send it out like a pulse, and breaking it up, and then it's reassembled on the other side based off of sequence numbers. But through the data link to the physical layer, the bits are converted to electrical pulses on the wire, and then it gets pushed across, whether it's copper or fiber, over to the other side of Paradise or wherever you're sending it to. So at a high level, that is the OSI layer, and